Good morning, HVAC team. So as promised, I'm going to go over some of the homework questions from Unit 7, I believe, because there were some questions about specific gravity that confused a few people, and there are some formulas in there, and like most of us, you know, that throws people, including myself, I get thrown off once they get into all these formulas and mathematical equations and stuff, and you're going to run into that a lot throughout the course. There's formulas for figuring out Ohm's law and, you know, figuring out uh, voltage and amperage and all these different things. And then there's formulas on how to figure out superheat and subcool, target superheat, target subcool. There's formulas when trying to figure out the specific gravity of something. So it's going to come up from time to time, but don't panic. Don't let it, like, you know, stress you out. Don't feel like you're expected to remember all this stuff, like you're going to be in the field and somebody's going to randomly ask you, quick, how do you figure out the lock rotor amps of a compressor? Like, it doesn't happen. That you're not expected to be like a walking encyclopedia and just have all these facts and these formulas committed to memory. They exist for your reference when you do need to figure something out. Just to comfort you guys, all of our testing equipment is digital and they do all the math for you, from our gauges to our multimeters. Not to say that you don't need to know this stuff, but you don't need to panic. When it does come down to the time to figure out how to do something, you can just refer back to the formula. Even if you don't have it remembered, you can refer back to your notes, or if you're out in the field later down in your career and you forget how to calculate something, you can always Google it. You know what I mean? But so, and for the homework, for example, you don't have to remember the formula. You just have to know that it's there and it's in the book. So you definitely want to read the chapters before you tackle the review questions. Or it's okay to try to knock out the review questions first and then go back and read the chapter, because some of the stuff you might already know, and then the stuff that you don't know, once you read it, once you come across certain facts, you'll be like, oh, okay, I remember that from the question, and then you could go back to the question. So however you do it is up to you, but everything is right there in the book. So, all right, let me go ahead and share my screen and get right to the homework questions. So I'll start with number 6, because that's when it got into the formulas and stuff. So number 6 on review questions, unit 7 review questions. Number 6 says, if a gas with a specific gravity of 1.33 was released into a room, it would most likely be found near the floor. True or false? Well, that's going to be true. Why is this true? Because if a gas with a specific gravity of 1.33 was released into a room, it's going to sink near the floor because it's heavier than air. So I put together these little notes for you guys. So the specific gravity of air is 1. Is 1.33, which is in the question, is 1.33 a larger number than 1? Obviously, we all know that it is. So being that the gas has a specific gravity of 1.33, when it's released into the room, the air in the room has a specific gravity of 1. It's lighter than this gas, so the gas is going to fall to the floor. So that's all they're saying. How do I know that the specific gravity of air is 1? Because that's what it says in the book. So it's a constant. Everything that I put on these notes in red is a constant. The specific gravity of water is 1. The specific gravity of air is 1. The density of water is 62.4. The density of air is 0.075. These are constants. These don't change under normal conditions. These don't change. You don't have to try to figure these out in order to get to, you don't have to do an equation to figure out those facts just to get to the equation that you're trying to figure out. These are a given. So if we know that the specific gravity of air is 1, then any number larger than 1, that gas is going to sink or fall to the floor because it's heavier than air. If it's lighter than 1, then it's going to float up towards the ceiling because it's lighter than air. I think I said lighter before, but you know what I mean. If any gas has a specific gravity heavier than 1, or larger number than 1, it's going to fall towards the floor. It's heavier than air. Any number smaller than 1, that gas will float up towards the ceiling because it's lighter than air, like helium. So Number 6 is true. Now let's go down to number 7. If a solid with a specific gravity of 0.048 was placed in water, would it sink? Or it would sink. True or false? That would be false. Why? Because 0.048 is a smaller number than 1. And again, if we refer back to our notes, the specific gravity of water is 1. Any number lighter than that will float on water. Any solid with a specific gravity heavier than 1, it will sink in water. Solids are compared to water. The specific gravity of a solid is compared to water. The specific gravity of a gas is compared to air. So any solid with a heavier specific gravity than 1, it will sink in water. Any gas with a heavier specific gravity than 1 will fall to the floor in a room full of air. So number 7 is false. Something that light would not sink, it would float. Number 8, what is the specific gravity of a gas that occupies 20 cubic feet and weighs 2 pounds? So now it's getting crazy. Now they're asking you some more off the wall, Einstein level stuff. Not really. It's, you know, it's pretty simple, but it's just unfamiliar at best to those who haven't, dealt with these type of equations before, including myself. Before I got into this trade, that kind of stuff never crossed my mind. But it's simple. You just got to break down what they're asking you. So they want to know what's the specific gravity of a gas, and then they gave you the properties of that gas. They've given you the tools or the numbers that you need for your equation. So we're trying to find specific gravity. Well, how do you find that? Well, it's in the book right there on page 63. It tells you to find the specific gravity of a solid. You need the density of that solid divided by the density of water, and then you get the specific gravity. Or if it's if you're trying to find the specific gravity of a gas, you would take the density of that gas divided by the density of air, and then that gives you the specific gravity of that gas. So I forget, are we dealing with a gas right now? No, we are. Yes, we're dealing with a gas. Number 8, the gas, and these are the properties of that gas. 20 cubic feet in volume, 2 pounds. So again, to find the density, the specific gravity of this gas, that formula that we just looked at told us we need to find the density of the gas and divide that by the density of air. So we need these 2 factors to find out the density of that gas. Where's that formula? Also on page 63. Is it 63? 83, sorry, it's page 83, unit 7. We need to find the density of that gas. So the density is down here. So we need the weight divided by the volume. The weight is 2 pounds. The volume is 20 cubic feet. So pull out my calculator here. So 2 divided by 20 gives us 0.1. So now we have the density of this gas. The gas that they're asking about has a density of 0.1, and we're trying to find specific gravity. So to do that, right here, we need to divide the density of that gas, which is 0.1, by the density of air, which is a constant right here in red, 0.075. So 0.1 divided by 0.075, and that gives us a whopping 1.33. So the answer to number 8 is A, 1.33, because 2 divided by 20 gives us a density of 0.1, and that density is then divided by the density of air, which is 0.075, and then the answer is 1.33. 0.1 divided by 0.075 is 1.33. So number 8 is A. Number 9. What is the specific gravity of a solid that occupies 3 cubic feet and 9 pounds? So we have to find, they're asking for a specific gravity again, but now we're talking about solids. So, but first, again, we got to find the density, which is the weight, which is 9, divided by the volume, which is 3 cubic feet. So 9 divided by 3 gives us 3. So now we want to divide that density that we just got. We did the weight divided by the volume, and it gave us a density of 3. So that 3 now is going to be divided by the density of air. Oh no, I'm sorry, we're doing solids now. So that 3 is now going to be divided by the density of water, which is 62.4. And I can't do this in my head, so I got my calculator. So 3 divided by 62.4 gives us a specific gravity of, so let me just go back. So right here in green, that's our formula to find the specific gravity of a solid. So the density of that solid was 3. We divided it by the density of water, which is 62.4, and it gave us a whopping 0.048. So on number 9, the specific gravity of a solid that occupies 3 cubic feet and weighs 9 pounds is C, 0.048. And then last but not least is number 10. What is the density of a gas that occupies 20 cubic feet and weighs 2 pounds? So they're asking for the density. So we already know to find the density, we have to we have to divide our weight, which is 2, by our volume, which is 20 cubic feet, and that gives us 0.1. So number 10 is D, 0.1 pounds per cubic foot. That is the density of a gas that occupies 20 cubic feet and weighs 2 pounds. So it's pretty simple when you know what they're asking for. You just have to break down the question and look at what they're asking for. And once you identify what they're asking for, then you have to refer to your book to find out how do you get them what they're asking for. And it's all right there laid out. Certain things, to me, I had to make things make sense. This is what I would have done as a student. I put this together for you guys because this is just how I think naturally. I'm like, okay, I need to see what's what. How do I make sense out of this? Okay, well, specific gravity of water is this, the specific gravity of air is that, the density of water is this, density of air is that. Okay, I got my constants that they're asking me for. How do you get the density of something? How do you get the volume of something? And it's all right there. So I snatched it out the book, put it on some notes that make sense to me. So now I'm not looking at 5,000 words. I'm looking at the ones that apply to the problem I'm trying to solve. And I got them all right here. So with all these rules that I wrote down, there's nothing you can ask me about specific gravity, volume, and density that I can't figure out. It's all right here. I got the formula to figure out my density. I got the formula to figure out my specific volume, which is the same factors as density, just flip the opposite way. Weight divided by volume gives you the density. Volume divided by weight gives you the specific volume. I have my formula here to get the specific gravity for both gas and water, and both of those are going to correspond with the densities of gas and water. Those are constants. Everything is being compared to either water or air, and the specific gravity of both is 1. Those are also constants. And so there it is. And these are the simple rules. Anything lighter than 1 is going to float. Anything heavier than 1 is going to sink. I got it written in blue. Same over here with air. Anything heavier than 1 will fall to the floor. Anything lighter than 1 will float towards the ceiling. For gas. So gas and solids, they act similar, but one's a solid, which is being compared to water. The other one's a gas being compared to air. Doing the same stuff. So simple stuff. So anyway, I hope that was helpful. I hope I didn't go too fast. But it's a recording, so you can feel free to pause, rewind, do whatever you got to do. Take screenshots of these little notes right here. Can I make it? No, I can't, but it's all right here. A little bit more at the bottom there. So take your notes, do what you got to do, but hopefully that was helpful. Again, I haven't done this for a lot of the questions, but I was getting a lot of feedback about this one, so I decided to just kind of break it down really quick. But the main thing that I hope you took away from this is that what you need is in your book, and the best way to get to solve a problem or to understand something is notes. Look in the book, look at the question, identify what they're asking for, and extract facts from the book that deal specifically with that. Make your notes like I put together right here, and then you can figure out the answer to all those questions. So anyways, hope that was helpful once again, and I'll see y'all on the next one.